In the 18th century, there were two types of industrial organization prevalent in all over in all the parts of Europe. The dominant mode of industrial production tended to be the urban-based guild regulated system. The guilds were clusters of producers or entrepreneurs based in the cities who took all the important production related decisions. So, what to produce, how much to produce, how to produce, for whom to produce, all these decisions used to be taken by the guilds. While this suited the requirements of the traditional products, the traditional manufactured products in any part of Europe, the problem was this kind of a system, because of its very tight regulation, could not adjust to changes in the market. So, if a new demand was generated for an old product, or a demand was generated for a new product altogether, it was very difficult for a guild-based system to work this thing out. So, for a long time, right from the 16th century, there was a parallel manufacturing system that had developed, which we have mentioned in the previous lectures. This is known as simply the putting out system. What happens in this system is that a merchant would put out materials or would purchase artisanal products from the artisans, which is to say that a merchant would, if he required something specific, he could go to the village artisan who produces this thing, buys it from him and sells it in whichever market he wants to sell. Alternatively, he puts out the material, meaning he gives the artisan the raw material is then manufactured into a product by the artisan, and the merchant simply walks off with this, paying the artisan whatever is due to him. The problem with and the advantage of this system, of course, is then the merchant can put out as much raw material as he needs in order to have as much products he needs to manufacture. The downside of this system, of course, was that for all practical purposes, the merchant did not have any control over the production process itself, because as everywhere in the world, so in Western Europe and definitely so in Britain, most of the time an artisan was also an agriculturist. In fact, he was only a part-time artisan, but a full-time agriculturist. So, during the agricultural seasons, during the harvest seasons, the artisan would simply not be available for industrial production. He was busy tilling his soil. Only when there is a lean season, there is no agricultural activity involved and he needs money, that he is willing to work on behalf of a merchant. In the second half of the 18th century, given the expanding demographic base of the British Isles, merchants in Britain were much more keen on investing in textile industry, which was one of the basic necessities. As a population grows from 6 million to say 9 million in a matter of 70 years, the requirement to clothe this extra population meant there was a steady market which was ready and asking. So, money needed to be invested. For the merchant, however, the question was, would there be control over this production process? Because there is a steady market, it had to be catered to. It could not be left to the whim of the artisan as to when he needs money and when he is willing to work. So, one of the fundamental changes that takes place in the cotton textile industry is that the need to generate more merchandise, the need to produce more clothes, makes the merchant willing to invest upon the condition that he can control the process of production. So, in the second half of the 18th century, you see the rise of things that we workplaces that we speak of first as workshops, which are smaller in size, and then you speak of factories, which is a short form of manufactories, places where manufacture takes place. The advantage of concentrating production in a workshop or a factory as against the artisan's cottage was very clear. If a merchant was producing on a mass scale in the earlier system, he would have to put out his material to a large number of merchants. So, he has to put them out and then he has to collect it over a large physical space, loss of time, loss of money. If instead production was to be concentrated under a factory shed, in a workshop, in a factory, where the laborer would come in, where the artisan would come in to produce whatever merchandise was required, then it helps the merchant to control the process of production. The production was to be regulated now by the clock. So, it begins at a particular point of time, it ends at a particular point of time, and factory production in this way was sort of bringing the entire production process under the control of the merchant, who knows exactly when the production begins, exactly when the production ends, and in between he can monitor the process of production, so that there is no laziness, no idleness, no foot dragging in terms of production, so that the market can actually be, the market demand can actually be met fairly conveniently. There are, generally speaking, 4 stages in the making of a cotton cloth. First is the process where the fiber is drawn out from the raw material, which could be cotton, which could be wool, depending on what textile we are talking about. It is the fiber being drawn out, that is the first stage. The second stage is when that fiber is spun into a yarn. This is known as the process of spinning. Then the fiber that is spun is placed, it is woven together, the yarn. There is a horizontal arrangement which is called the warp, and there is a vertical arrangement which is called the weft, and fibers are sort of intermeshed alternately, one warp and one weft would then be woven together into a cloth. That is the third stage. This is called weaving. And then comes the fourth stage, which is finishing, at which stage a fabric would be dyed, it would be colored, it would be printed, and so forth. In the British cotton textile industry, the change that really takes place comes with the Kay's flying shuttle, which was devised in the 1730s, then to mechanize weaving, which began to spread in the 1750s, when 3 or 4 spinners were no longer enough to supply one weaver. The flying shuttle then propelled the invention of something called spinning jenny by a man called James Hargreaves, who invented it in 1764, which was patented in 1770. Spinning jenny was not the first machine used for purpose of spinning the yarn. Nevertheless, it becomes one of the pivots of mechanization of cotton textile industry, because we have to understand that all the inventions pertaining to cotton textile industry, apart from the first one, flying shuttle, happen to be in the spinning segment. Flying shuttle was the only machine that had to deal with weaving. James Hargreaves' spinning jenny in the first stage had 8 spindles, which basically means that one machine would do the work of around 8 spinners. By 1774, the number of spindles was raised to 16. It became 80 in 1780, and by 1800 there were jennies with as many as 120 spindles, which meant now that in order to cater to the needs of a weaving machine like flying shuttle, a machine like spinning jenny was displacing spinners by a factor of 1 to 120. Following on the invention of spinning jenny came Richard Arkwright's water frame in 1769. The quality of yarn spun in England before the coming of the water frame was not very good. The invention of water frame removed the problem of brittle cotton yarn. In 1779, Crompton's machine called the mule brought the virtues of spinning jenny and water frame into the same machine, improving the quality of both the yarn that was spun and the cloth that was woven. The quality of cloth by 1800 was definitely superior to even Indian textiles. With the invention of the Boulton and Watt steam engine in 1785 and its eventual deployment in the water frame of Arkwright, the productivity of water frame was sort of increased even further. And in a very fortuitous manner, in the year 1775 itself, the patent of water frame lapsed. It was not renewed. As a result, the tendency to proliferate the use of water frame used to grow. The machines, however, were fairly expensive, and the artisan being unable to afford them, the entire process of production now began to be shifted to the workshop, the factory that we were already spoken of. With the mechanization of the production process, cotton textile industry gradually came out of its relative insignificance in 1760s to the position of the most significant industry in the British economy. In 1802, 4 to 5% of British GDP came from cotton textile industry. By 1812, it managed to displace even woolen textiles as it began to account for 7 to 8% of the GDP. By that time, more than 100,000 people earned their livelihood as spinners, and nearly 250,000 people were employed as weavers. In 1815, of the total indigenous British exports, over 40% were cotton textiles, whereas woolen fabric amounted to a mere 18%. By 1830, more than half of all British indigenous exports happened to be cotton textile products. There were interesting changes in the realm of prices as well. In 1876, a pound of cotton cloth came for 38 shillings. In 1807, it came down to 6 shillings and 9 pence. Hence, the domestic demand for cotton increased several times over. British iron industry was the only industry in the history of Great Britain to have begun its mechanization process sometime in the 16th or 17th century. In fact, one full century ahead of textiles. It was organized along capitalistic lines, it was organized along the lines of factory-based production rather than an artisanal production, but it did not generate any multiplier effects simply because there were technological problems associated with British iron. For historical reasons, for reasons of natural endowment as well, the British could not produce anything higher than pig iron. For more durable varieties such as cast iron and wrought iron, the British needed to import Swedish iron. The reason was the iron ore that you find in Great Britain tended to be inferior in quality. It had, that is to say, a large amount of impurities, meaning other minerals, other items that would be sort of lying embedded in the ore. So, for a strong iron to be produced or strong metal to be produced, what you need to do is clear out the impurities. Now, in Britain, till the middle of the 18th century, as we have already discussed in the previous lecture, the standard source of standard inanimate source of energy tended to be charcoal. So, the furnaces which were used to sort of burn out the impurities from an iron ore before the ore was molded into the iron, the standard energy source happened to be charcoal. Problem with charcoal was that it did not generate adequate heat which could blow out the impurities. From the second half of the 18th century, the British, as the charcoal deposits, the charcoal reserves began to deplete, the resources began to deplete, a number of British ironmongers began to shift to the alternative source of inanimate energy, which is coal. Now, coal, while charcoal was easily available, used to be fairly expensive. But at a time when charcoal was becoming expensive, coal was becoming relatively more useful. Thus, in 1760, you have a situation where in Great Britain, the number of furnaces run on coal was growing up to 14. In 1775, however, the invention of steam engine by Boulton and Watt opened up new horizons of possibilities in the iron industry. The quality of iron produced by those furnaces that were operated on coal proved to be so much better that a larger number of ironmongers in fact actually began to shift to coal based furnaces. By the 1770s, the number of coal powered furnaces doubled, and the last of the furnaces run on charcoal was manufactured in 1770s. After 1770, all the furnaces that were built were powered by coal. In 1790, the number of coal furnaces increased to 86, while those run on charcoal came down to 25. And along with this, a very long standing feature of British iron industry, its peripatetic nature, it tended to move around from one place to another depending on availability of charcoal. So an ironmonger was unlikely to be located anywhere for certain. By the 1790s, you have a situation where the iron industry becomes rooted to an area which was either close to the iron ore, the iron deposits, or alternatively coal deposit, because coal was becoming so important to the process production. Another problem which emerged in association with the use of coal happened to be the fact that coal tended to introduce a fresh set of impurities. So while charcoal did not generate adequate heat to clear out existing impurities, coal could do that, but in the process coal would insert fresh impurities in the ore. So the iron would continue to be fairly weak. This problem was solved by the innovation called the puddling and rolling processes, which was devised and patented by Cort in 1784 and 85 respectively. The quality of iron improved so much as a result of this Cort's process of puddling and rolling, that British pig iron, which is a more inferior quality of iron, became as strong and as durable as Swedish wrought iron, which is the best quality. As a consequence, in 1810, it could be seen that while a ton of Swedish iron cost 35 to 40 pounds, British iron would cost only 18 to 20 pounds. Once the cost of iron falls, a large number of instruments, machineries, objects that would previously be used made of either copper or even wood now began to be made of iron. So Arkwright's water frame or spinning jenny, the wooden frame, what happens is when the spindles begin to run very fast, the water frame would sort of start shaking, and then after a time it could just break. With the use of a durable quality of iron that was introduced, the machine lasted longer, it becomes more durable. As a result, it helps in the proliferation of the innovations in the textile industry. So iron industry had a new set of demands which will be now being generated by cotton textile industry, and because this new demand was being generated, ironmongers were willing to invest more in technology such as the Cort's process, or such as inventions such as steam engine of Boulton and Watt. Thus in turn, the rise of mechanization in cotton textile industry triggers some developments in the British iron industry. Now for iron you need coal, so that triggered innovations in British metallurgical sector. So coal reserves, which were previously much more deeply buried in the ore, would now be accessed using better quality iron. The better your quality of iron, the deeper you can bore, and the greater the amount of coal you can generate. So cotton textile generates a set of demands which has a which has a multiplier effect on iron industry, which in turn generates some need for innovations in the metallurgical sector. The impact of the simultaneous introduction of the new production system in textile and iron industry was therefore readily visible, because the iron industry witnessed a transformation which was no less dramatic than the one in textile industry. In 1760, Britain produced 60,000 tons of pig iron. In 1800, the figure went past 250,000 tons, 4 times, more than 4 times in a matter of 40 years. In 1800, the iron industry contributed 6% of Britain's GDP. In 1800, Britain contributed 19% of the total global iron output. In 1820, the figure was 40%, and in 1840, Britain was producing half of the total global per output of iron. When coal was being dug out of the mines, it had to be taken to the iron industry. Now, coal is heavy, and it's very difficult to transport if you are going to use a bullock cart or a boat or anything like that. However, with the invention of the Boulton and Watt steam engine, it was possible to drag a large number of carriages of coal by a machine which was run on steam power. And this machine, this wagon, used to run on rails. This is the beginning of railways. Coal was taken from the pit to the iron industry, to the iron factory, the foundry. Once the iron product was ready, it had then to be shipped to the port. In order for the iron to be transported from the foundry to the nearest port, again railway began to be used. Once the convenience and the economy generated by the railways began to be visible, railway was opened up for more commercial use. So, what began essentially as a system of transportation within the factory gradually began to sort of traverse the length and breadth of Great Britain. By 1840, Britain witnesses a major second generation of industrial revolution, as it were, with the emergence of the railways for the purpose of not only mass goods carriage all over Britain, but also mass transportation of people, of man and material both. Therefore, railways tended to open up the horizons. With the gradual physical integration of Britain becoming much more effective, much more cost efficient, the quality of there was a qualitative change in British economy as transportation became revolutionized, as the larger distances could be covered as a result of the use of railways. The effective marketability of any goods began to magnify several fold, and Britain moved into what is known as the second generation of industrial revolution, because the moment the railways becomes an option of mass transport, then you need more demand for iron, it generates more demand for iron in order to manufacture the rails, in order to manufacture the wagons. That requires also that generates also a greater demand of coal, because it would be, the railways would ultimately be run on steam power, and it would need coal would be needed in order to generate more and more iron and dig out more iron ore. So, all of these put together tended to sort of stimulate British industrial production to a level where by the middle of the 19th century, Britain was already the industrial powerhouse of the world. All other economies, by comparison with Britain, were automatically backward. Britain had mechanized textile industry, and not only that, almost all industry could see the advantages of the use of machines and use of inanimate source of energy over animate sources of energy. And with a textile revolution, with an iron, with a heavy industry revolution, and with a transport revolution, Britain was so far ahead that all the other economies